We continue with our lessons in algebra. We have just looked at expansion, and I'll encourage you to check out the video in the playlist and see the basis of expansion. But there is more to expansion that we need to look at. And in this topic, we will begin with expansion, and we will realize that depending on the question you are given to expand, you may also need to simplify to solve the problem completely. So what I mean is that sometimes after expanding an expression in algebra, you end up with what we call like terms. Like terms. And for us to present our final answers in a more matured way, it is recommended that we group all like terms. The process of grouping all like terms and solving any arithmetic problem in an algebraic expression is what we call simplification. Simplify. So sometimes you set out to expand an expression and you end up having to simplify in order to give your final answer in a more appropriate expression. So that is what we will be looking in this lesson. We will also look at something that is very important when we have negative numbers in our expressions. They can change the whole expansion. And we looked at negative numbers when we were at the start of this channel, when we were looking at numbers, topics in numbers. One of the main subtopic with a video is negative numbers. I'll encourage you to go look for that video and just update your knowledge on negative numbers. We'll be using that principle to also expand so that we can do things correctly. So let's see what we can do in this regard. So for instance, you are given the expression 2s into bracket 4 plus 3y minus s into bracket 2y plus 5. Okay, so let's say we have been given this relatively long expression to expand and simplify. Sometimes you'll be told expand and simplify. Sometimes you simply be told expand. Okay, but even if you are simply told expand, the expectation is that if your expansion results in like terms, you will reorganize the like terms. If there are arithmetics, for instance, there is 9 here, there is negative 6 here, we will be expected to bring them together and simplify and leave it as 3, not writing 9 and negative 6 in the same expression. So that is what we want to look in this short video. So let's go ahead and solve this. So using the skills that we learned in the first video on expansion, we know that this one can be expanded as 8s plus 6sy. And then we come here now. This is where I wanted us to pay attention to the negative. What some students usually do is they see this negative as separate from this term x, and then they go ahead and ignore this negative and try and expand with this s. But that is not the correct way to look at this. The correct way to look at this is to always consider the sign that comes just before any term in algebra. The sign that comes just before any term in algebra. So what is actually happening is that this is not x, this is actually negative x. So we are going to expand this with negative. And this gives us an opportunity to learn how we expand brackets when a negative is sitting outside the bracket. So here, what happens is that minus s goes for 2y, and that becomes minus 2sy, and then minus s goes for plus 5, and again that becomes minus 5s. Okay, so here we have expanded as we were told, but this is not a very matured way of presenting our final answer. Why? Because there are many like terms in this expression, and the expectation is that we will reorganize it, simplify all the arithmetic, simplify all the like terms, group them together, and then we can have a more simplified expression. So let's carry on with that. What are the like terms? First, let's try and identify the like terms. So first of all, we have 8x, okay, and negative 5x. They are like terms. Now, in algebra, what makes like terms? When we are talking about like terms, we are looking at the variables that are attached to a coefficient. We really don't care about the coefficient because the coefficients are always numbers, and that is not a problem. The coefficients in these expressions are numbers. That is not a problem. But what makes us identify terms as like terms? What makes us identify terms as like terms are the variables attached to the coefficient. So here we can see sy, and here we can see sy. Okay, don't worry about whether it is negative or positive. Focus on the variable sy. So these two are like terms. So I've grouped them with the yellow bracket. And then here we can also see this as s attached to this coefficient 8. And here we can see this s attached to this coefficient negative 5. So they are also like terms. So simplification, first I like to reorganize them. So I'm going to bring my 8s, and then I'm going to bring my negative 5s. So this is what we call grouping like terms. You see, I'm bringing all the terms with variable x on one side of the expression, and then I'm taking all the other terms with sy onto the other side. So here I carry on with my plus 6sy minus 2sy. Okay, now how do we carry on with the simplification? This is where I need you to make some mental connection. So for instance, you go to your kitchen and you have a bowl and there are 3 oranges in one bowl, and another bowl has 4 oranges. If you want to put both together, you are going to get 7 oranges. Okay, and we can use this analogy in algebra. Let's assume that this s is orange, this s is orange. We are bringing them together. Here we are subtracting. So what we need to do is that 8 minus 5 is 3, and then the s is maintained. Okay, so if we want to simplify this, it's like I have 8 oranges. I've given out 5 oranges. How many oranges do I have left? 3 oranges. Okay, I have 8x. I've given out 5x. I'm left with 3s. So that is how you simplify it. Don't think that once you are subtracting, this s is going to subtract this s to be 0. No, it doesn't work like that. Okay, variables attached to a coefficient, when they add or they subtract, they just maintain their identity. They don't subtract or add away. Okay, I hope you understand. And then here again, we are looking at the variable of sy and 2sy. So we can pretend that sy is banana. Okay, so I have 6 bananas. I'm taking out 2 bananas to give to my little brother. How many bananas do I have left? 4. So it's going to be plus 4sy. So that is how we go through simplification. So what is the procedure? First, we look out for like terms. We must be sure what is a like term to what. Then we reorganize the whole expression to group the like terms. Then we apply the principles of arithmetic to simplify them. So if they are subtracting, we just carry on as if we are subtracting 5 from 8, for instance, in this case, or we are subtracting 2 from 6, and then we will end up with a simplified answer as that. Okay, so when you are simply told to expand this expression, don't leave your answer as this. That will tell us that you are not really very matured in mathematics. You have to go ahead and simplify, and then you can get an answer that looks like this, which let us know that you are really very matured in maths. Let's try another example just to reinforce everything that I've spoken about. So you could be given an expression like this: minus a into bracket b plus c minus b plus c. And then you are told to expand this. Sometimes, if you are fortunate, the question will say expand and simplify. But sometimes it will simply say expand. But even if it simply says expand, and you expand and you come across what we call like terms, as I've explained earlier, then you will have to simplify the like terms and present your answer in a more matured, complete way. So let's look at this simple one. And I've chosen this example because of the negative. So we are going to try and first expand to remove the bracket, then we continue with the other parts of the expression. So minus a times b is going to give us minus ab minus a times plus c is going to give us minus ac, and then we have minus b and then plus c. Okay, so here, that is where we are. There are no like terms. There are no like terms. And don't mistaken this A to be a like term to the other one. No. When you are looking out for like terms, you consider all variables attached to a coefficient. If they are exactly the same, then they are like terms. If they vary, they cannot be like terms. So for instance, here, although I have A, it is AB, and AB is not exactly AC. Although A and A are the same, they have different variables attached to them, so they cannot be considered as like them. So in this expression, this will be our final answer. We can't do anything more to it. We can't simplify it any further. That is where we will have to leave our answer. Let's look at one more example, and then we can bring our video on expansion and simplification to an end. So you have let's look at an expression like that: 3t into bracket 5t plus 4 minus 2t into bracket 3t minus 5. Okay, so let's solve this together. You can get a piece of paper and a pen and solve alongside and see what you get. Or you can pause the video, solve it, and then continue with the video and see where you are, because at this point you really have gotten all the principles and you should be able to apply it to solving a problem like this. So first of all, I like to expand and take out the brackets whilst respecting the various signs that are in front of the terms. So here, positive 3t. So this goes here and gives me 3 goes for 5, 15. T and t gives me t squared. Now this goes for that, plus 12t. So I've expanded that bit. Okay, now I'm going to also use green to expand that so that we can see the different parts of the expressions being expanded and then apply it to our solution. So here, negative 2, as I said in earlier, this is not 2t. This is not something minus and then 2t. This is negative 2t affecting everything in this bracket. So we are going to get negative 6t squared. And then here, if you remember from our video on negative numbers in number, the major topic number, negative multiplying another negative number results in a positive product. Okay, so negative 2 multiplying negative 5 will become positive 10. And then the t, don't forget the t comes. So that is the first line of we get after expanding the question that we were given. But I think there are like terms. So let me use blue to group some like terms, and then I'll use yellow to group other like terms. So t square and another t square, they are like terms, so I'll be moving them to one side. Then t and t are like terms, so I'll move them to another side. So let's start with the blue team. I'm going to get 15. Sorry. I need a color for the blue team. So 15 t squared minus 6t squared, and then now I continue, plus 12t, okay, plus 10t. So if you see, I'm respecting the signs in front of the terms. Okay, if it's negative, I respect that negative and move it as such. I don't just move 6t and leave the negative floating in the universe. No, it is minus 6t squared, so I have to bring it all. Okay, so now simple arithmetic, 15 minus 6 gives us 9, and then the t square comes, plus 12 and 10 gives us 22, and then the t comes. Okay, whenever you are confused about adding algebraic terms, think of them in terms of oranges. So 12 oranges plus 10 oranges will give me 22 oranges. So 12t plus 10t must give me 22t. I'm pretending that t is orange. Okay, so that is what we do. So this then becomes our final answer. It is expanded from the expression given us and it has been simplified. And so we have this. This brings us to the end of our video on expansion, where we have now looked at what happens when an expansion results in like terms. When expansion results in like terms, we must simplify. And so we have looked at the procedure in simplifying algebraic expressions in this video. So this brings us to the end of this video. I hope that you have learned something that you can hopefully apply to solving some math problems that you are given in school or in an exam. Next time, we will be looking at factorization. So stay tuned and then look out for our next video on factorization, another very important skill in algebra. Thank you. Have a good day. Bye.